Hello and welcome to this lab guide video where we will be doing another GCP/web application lab, and this lab is going to be called Exploit SSRF with Gopher for GCP Initial Access. So if you're not familiar, Gopher is a protocol, quite outdated, but is still usable. And so what people are using it for is to use these SSRFs that require headers. And I'm going to show you how that's done in this lab. Let's go ahead and get started. We have this IP. And first thing we should do is to nmap it. I'm going to run a quick aggressive scan over it. And while I'm doing that, I'm just going to explain as well that I already ran my VPN file. Now, this is crucial because you're going to find if you didn't run the VPN file, you're going to be encountering problems connecting to this host or nmapping it to begin with. So all I did was I copied this the VPN file over to my virtual machine and ran it with OpenVPN. Now, that's kind of the way that I'm transferring the VPN files, currently at least, is so you just press this download button, download VPN file, then you're going to download it, and then I open it, I select all, I copy, and then I paste it into a file on my virtual machine, and then run OpenVPN. So with that being said, let's go back to our nmap scan. Looks like we got the scan output. We have port 22, so SSH is open by default, I believe. And then we have port 80, HTTP title, gigantic retail. So that is the corporate target that we are hacking or attacking in these GCP labs. So that's quite standard. Let's go ahead and check this host out. Actually, instead of running it on the browser, since we're going to be doing some SSRF, some web exploitation, let's go ahead and start up our Burp suite. Now, if you're not familiar, your Burp suite is a tool and proxy for attacking web applications. Using the community edition, which is completely free. So if you go over to proxy and open the browser, you'll have a proxied browser right off the bat. Okay, so incredible. We have got this web application to work and we are connecting to it. So a bunch of problems with the VPN, but that's for another video. So anyways, now that we're here, let's go ahead and do the first thing that we should always do, which is let's check the source code. Actually, before even touching the source code, I know that we're doing a GCP lab, but can we confirm that this is being hosted on GCP right now? Let's do it. Google. Amazing. So we know now that this is being hosted on Google, meaning this is a compute instance. And now with that being said, since it's being hosted on Google, I bet you that it's also using Google resources such as buckets in order to host or serve its assets, such as any of the files or the scripts or image assets, videos, things like that. So let's go ahead and search in the store in the source code. Let's search for storage. Okay, it doesn't seem to be anything here. Let's shop now. Home, about us, contact us. Not working. Shop is working. Let's check this page. Storage. We have gigantic retail, a exposed bucket, gigantic retail, gigantic retail. So not much more than that, but we do have one bucket name, and that is a win. Already we have a complete disclosure under our belt. So that's the first vulnerability. Now let's go ahead and check out the files and directories that we can fuzz in order to see if there are any disclosed pages that are meant to be, hidden or secured by obscurity. We can find obscure files. We can find hidden files and directories through fuff. So using the fuff, let's go ahead and use the buckets.txt again. And instead of this website from an earlier lab, we're going to be fuzzing this. All right, 11,000 requests to go. Okay, so now that we're here, let's see what's going on in Burp. So if we go to our history, let's actually clear this and then run this page again. Okay, just a simple get method request. And source code, which we already analyzed. All right, let's click some buttons. Add to cart. It's like add to cart is not producing any requests. Add to cart. Check nearest shop. Okay. That's not a request either. Cart. That's not a request either. City. City 1. Not a request. Profile. That's okay. That's a request, I think. Okay, so we got to profile.php. You know what? Before we hone in on profile.php, let's go ahead and make sure we didn't miss any clickable pages. Right here, it found profile.php as well. However, let's go ahead and use a crawler to make sure we didn't miss any pages that could have been clicked or could have been reached. All right, so let's use this GoSpider. I think that should do. It's like it's not installed. Install it real quick. All right. GoSpider-S. Okay, so plugins.js might be fruitful. If we find a vulnerable plugin, that's still a win. Isn't it shop? Shop.html. See if there are any crawlable pages here that we missed. Okay, doesn't seem to be anything interesting in this crawl. However, what we did find is this juicy profile page with a bunch of fields here for us to test. So let's go ahead and test them. All right, let's see what happened here. Okay, so it looks like there's a parameter here that's being used within the request called URL. And if I know anything, is that URL requests are the most subject to SSRFs. So let's go ahead and snag this request, send it over to repeater. Could not resolve host AAAA. So it's even returning our own input as output, which is another target in and of itself. However, what we're going after today is an SSRF, and that's pretty much because the lab title kind of gave it away. Let's go ahead and test for some SSRFs. I have a bunch of SSRFs here in my playbook. So if I search SSRFs, I go to my SSRF section. And the thing about SSRFs with GCP is that we need this header, metadata flavor Google. Without this header, we're unable to reach the metadata. Now, if you're not familiar, the metadata is an internal service which hosts and which maintains an API for the host itself to use in order to retrieve data. You can retrieve data like user data. You can retrieve all kinds of data about the host, about the virtual machine, and about the service account associated with that virtual machine. Now, what that means is that if we have access to this metadata service, we can get the service account's token that's associated with the virtual machine and then use that to move laterally and access the rest of the resources within the GCP environment. Of course, within the scope and within the permissions that we have as that service account. So let's go ahead and do that with Gopher. So I have this Gopher command, but I will explain it to you. In the request itself, I'll explain it. So let me go ahead and decode this. URL encoding. So let me go ahead and decode it. Decoding it twice. Okay, so as you can tell here, we're using Gopher as a protocol as it is prepended on the metadata Google.internal service API. So after that, we're going to be using the Gopher format, xget, and then specifying the directory or the file within this host. And we're going to be reaching all the way up to instance service account default token. And that's because this is the standard pathway. This is the standard path to the token that we want to retrieve. So with that being said, we're also able to, through Gopher, include these headers, include the host accept, metadata flavor, which is the most importantly. This is what's supposed to securely prevent us from exercising this SSRF. Yet through Gopher, we're able to include it and then URL encode it in order for it to work. So let's go ahead and do that now. I'm going to re-encode it and then run this command. Looks like it is taking a bit of time. Amazing. So it worked perfectly. And I mean, even before this, all right, let me snag this token and then explain something. Even before going all the way here to like going all the way to a Gopher SSRF, it would be quite simple to I didn't make another one. It would be quite simple to confirm that this is vulnerable to SSRF by just doing a simple request to localhost. I can see that it is in fact vulnerable to SSRF, and it can make requests to whatever we want. So yeah, let's go ahead and get back to the token and snag this token and get to the GCP hacking portion of the lab. So if you want to pause the video here and check specifically where I'm copying the token, it's right after the quote and this part right here, and then the same afterward. It's right before the quote, the end quote. Let's go ahead and save this token to my token file. And from here, I want to do one thing real quick. I'm going to try to access the storage. And the reason why is because by accessing a resource that we don't have permissions to access, we are actually disclosing the service account's name, and by disclosing the service account's name, we're disclosing the service account's project. So grproj1 is going to be the project. So if you're not familiar, bucket viewer is going to be the name. By default, this is the format, bucket viewer, and then @ and then after the @ is the project name, and then after the project name is this, which stays the same. I am gserviceaccount.com. So with that being said, let's go ahead and brute force our permissions in order to see what kind of permissions we have on this service account. And by the way, when I use the gcloud storage ls, I included the token file through this flag, access token file. All right, so let's go ahead and use this command here. Now, there are a range of tools for you to use in order to brute force permissions. The one I'm going to use, which you can copy and paste into Google right now, is called brute force my GCP perms. And this requires that you include the project name. Some other tools don't actually require the project name, such as GCP's, if you're familiar with that. You can Google it right away as well, GCP's GitHub. But this one does require the project name, and it requires the token, which all of them require either the token or a service account file or some sort of access, like a login. Okay, so with that being said, our service account is called storage, or what is it called? Bucket viewer. So because our service account is called bucket viewer, we can probably establish that this service account is able to view buckets. However, it's not able to view buckets, so I take that back. We can probably establish that this service account has something to do with viewing the contents of a bucket or retrieving the contents of a bucket, because its name is bucket viewer. Now, we'll confirm this once our scan here for permissions is done. But just based on the naming scheme, of the service account, we should probably search for a target bucket. Now, if you recall, when we were looking at the source code of one of these pages, we found that, oh, not this one right here. We found that they are using a bucket called Gigantic Retail. So let's go ahead and check if we have the ability to view as a storage viewer this bucket. Okay, let's do it. Amazing. So lo and behold, storage viewer or bucket viewer does have the permissions to view this bucket. And now that we're here, we see user data, which is juicy, and as well the juicy flag. So let's go ahead and snag that. Amazing. So we just got the flag. So I believe this might be the flag to win. Okay. Our scan is not done, but we might have already completed the lab. So let's go ahead and see. Incredible. That was an amazing lab. In terms of what we learned a lot about SSRFs. We learned the value and the utility of the Gopher protocol. And overall, please let me know in the comments below if you like this lab, what you found to be the most difficult part of it. And if there was something that you're struggling with, please let me know and we could talk about it either on the YouTube comments or on Discord. Thank you very much and see you later.